Live preparing. It says preparing to live stream the meeting.
Okay.
So hold on. Okay, let's see. It says preparing to live stream the meeting. All right, we're ready, Ron. As soon as I said preparing to live stream the meeting, it actually started recording on YouTube.
I heard
I'm
there
going
you
to
go. All right.
Mute that.
Okay.
You're on, Baron.
We're on the radio. Well, not exactly. Old habits are hard to break for me, everybody. Welcome aboard. It's the weekly podcast on Zoom of our South Coast Longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit, or SBAU for short. Isn't that a great name? I got to tell you, it's a once-a-week news wrap-up, if you will, of space stuff, albeit from a local level here. We'll call it the Meet the Press of Cosmology, or the Face the Nation of new discoveries, launches, probes, all kinds of visits to other heavenly bodies in the solar system. I'm your email MC, and we're online. We're on YouTube. My God, you can watch us live Mondays. My name's Baron. Proud to introduce you now to members of the club and the board of SBAU. Well, I just happen to call our brain trust. Got to tell you guys, these are some of the best minds in the town of Santa Barbara, if not the state or the whole nation. Very knowledgeable cats on the screen. I happen to be vice president, but I'm going to call myself the weak link, the inquisitive one from the radio. Ladies and gentlemen, welcome aboard for the third season. Our president, Jerry Wilson. Good morning, Jer.
Good morning.
And our incredible outreach coordinator, imagining somehow being able to pull off some outreach during the pandemic, Chuck McPartlin. How are you?
Can't complain a bit.
All right. And the webmaster at the top left of the screen, distinguished technician and a genius in his own right, Mr. Tom Totten, former President Thomas, and former Westmont College science instructor and editor of our incredible monthly newsletter, and a damn good sourdough bread baker, although he's not baking today, Tom Whittemore. How are you, Tom?
Good morning. Good morning.
You miss those kids, those young people in the labs, don't you?
A lot, yeah. I just sent Chuck the April issue, and you were prominent in it with a caption.
Well, I hope you didn't get a picture. I mean, this is bad enough. I got to look at myself, but I did get one article in there years ago, a couple of years back. You found it.
You could write some more.
You can write more. Always looking for it.
All right. So Jerry, President Jerry, you're not in there this week?
Oh, yeah.
This month? Okay. Tim Crawford is not on board, but he is one of our active members that's involved with Telescope. We're going to ask Tom real quickly before I go to some of the stuff we'll be talking about tomorrow night. We got a special guest, don't we? Bob Richards.
Oh.
For our telescope workshop, Bob is just going to show us and tell us how he did a astrophotography of galaxy M87 and got the jet showing up on M87.
Nice.
Is there another name for M87?
Virgo A.
Okay.
Virgo A and his orchestra.
Virgo A.
Well, how do people get on board that? Go to sbau.org first?
Yeah, they need to contact the webmaster at sbau.org so I know that they want to get in. But yeah, we've sent it out to all our members and a few other friends. So a lot of people know about it being available.
Well, this hour, ladies and gentlemen, it's Monday, the 28th of March. All 5 of our programs so far that have been archived, and we're doing the 5th one right now, have been in the month of March 2021, the second year of this awful pandemic. This is our 5th program, episode 5. We'll be into the Ides of April next week. And this hour, we're going to talk about, water on Mars and something in Cassiopeia, a new nova. But first thing I want to throw to President Jerry, since you sent out the notice on an email a week ago, a couple of days before it hit national news, NASA sent something to Mars on Perseverance and didn't tell us about it. What the heck was it?
It was a swath of fabric from the Wright brothers' first airplane that flew. I understand
Right out of
it's
the
about a postage stamp-sized chunk of cloth.
So they cut it off with the wing in the Smithsonian, I suppose.
The Wright family donated it. Maybe they had an extra piece of material or something. You know,
You
the Wright
suppo-
brothers never really cleaned up their shop.
Oh, so it's from the shop. It's not off the
Oh,
actual
I don't know.
display.
I was just being flipped there.
It
No,
also goes to show you that two rights don't make a wrong.
That's-
okay, we'll edit that. Okay.
it's Captain Punster. You know, we should probably throw it to him every week to give us the latest puns in Whittimore's.
And just to clarify,
repertoire.
today's the 29th, Ron.
It's the 29th.
Oh, did I miss a day? Okay, well, the Ides of April upon us are Wednesday or Thursday of this week. I think Thursday is the first, isn't it?
Ides of April is April 15, tax day, but they moved tax day.
Yes, they did, but I'm not talking about taxes. I'm talking about April Fool's Day. In fact, there's
That's
something
on-
you can do.
It's on Thursday.
Yeah, okay. So we got 3 more days. This is Monday morning.
Yep.
Regaining watchers, listeners, fans, and let's go to water on Mars. That was the gist of your main email, Mr. President.
A second addendum. Yeah. The
It's a big aquifer, isn't it?
well, it turns out that when they modeled the amount of water that that Mars lost in the early stages of billions of years ago, it turns out that the atmospheric loss did not match the model. So in order to make the model work, they had to assume that there was a tremendous amount of water on Mars to begin with. And the water could not have been lost through atmospheric evaporation, as has been assumed. And there's so many minerals on Mars that formed in the presence of water that it turns out the water is contained in aquifers under the surface and in minerals. And so they did a study at Caltech. Oops, wait, got to get that right there. So when the water in the, I guess, as Chuck said just before the meeting, that Mars has a larger and less dense core than the Earth does, or that was believed before. And so it turns out that geologically, Mars iron, which would be in the core if it were like Earth, is distributed throughout the mantle and on the surface. And that's why basically Mars has this rusty red color, because actually it is rust. It contains a lot of oxygen, and there's a lot of water in the minerals on Mars. It turns out there was enough, if I have to get the statistic here, the Mars originally had enough water to cover the entire planet between 100 and 1,500 meters thick. And most of that
Good
water
Lord.
did not leave Mars into space. It's inside Mars, embedded in minerals and stuff. So it turns out that's a tremendous resource for future exploration and colonization of Mars, because this water can be tapped. It's in the form of water ice. It's in the form of minerals. It can be used to make oxygen to breathe and hydrogen for fuel. So it eases the risk and improves the probability of colonizing Mars.
But it's in the form of ice,
Right.
and it's buried because it couldn't survive on the surface unless it's out of the sunlight on the poles.
Well, it could, if it were in a large body of water with the very low atmospheric density now, it would sublime into the atmosphere and it would slowly be lost. But that was not the mechanism of losing the water. Water went into, it happens on Earth too. Water sequesters into the core of the planet, into the mantle of the planet. But on Earth, we have an active volcanic system, or active geologic system. So the volcanoes spew that water back out into our atmosphere. They recycle it. Mars does not have an active geology, and it does not have any active volcanoes today that we know of. And in the past, it only had limited volcanism. So that water sequestered into the planet like it did on Earth, but it did not recycle back out.
And it's not all in ice, Ron. Some of it is in the mineral compounds.
Really?
Yeah.
It's still H2O, but it's bound with minerals, other
Well, for
compounds.
example, the picture that Tom had back up of Mars, you notice going across the general. Tom, could you put that picture back up?
Okay.
You see the planet is not there, that one. The planet is largely
It is.
red. So that's like water and iron forming rust. But you see there's dark material on the surface too. That's largely olivine, which forms in water, and it has water in it as a mineral.
Huh. Rust is made with the iron combining
iron.
with H. What?
Why? Iron,
My question is rust. Thought was like slow burning. It's combining with oxygen, but it doesn't inside the water molecules. H2O, not O2.
no, it takes the oxygen. If you put iron in water here on Earth, it absorbs the oxygen and becomes Fe2O3, iron oxide. And
Right.
that's where the reddish color comes from.
And then it releases the hydrogen back into the
Yeah,
atmosphere.
hydrogen is released, yeah.
So
And
what,
the
what do
same
you
thing
guys,
happened-
what do you
ahead.
guys think? Let me ask them, what would you guys think would be the best way to get the water out from the clay, the rocks that sequester the water? Be a lot of energy to burn the rocks or something?
I would call my friendly geochemist and ask him how to do that. That wasn't my field.
Well, they have the MOXIE on Perseverance is testing ways of taking the carbon dioxide in the atmosphere and breaking it down and getting oxygen out of it.
Mm-hmm.
Okay, but we don't look at Mars as having this huge sunken ocean under the ground. That's not technically what's happening, is it?
Apparently it does have that too.
It does?
Yes, but in the
Wow.
form of ice.
Yeah.
Do we know how we found this out from above, from the orbiters, or from one of the rovers?
Well, it's a combination of everything. We've been investigating it for years. You know, I forget the name of it, but one of our Mars probes landed up near one of the poles, and it was looking for water ice or water, and it scraped about a few centimeters of soil off the ground that it landed on, and it came to very, very hard ice. And so it didn't have to dig very deep to find the ice.
Can water evaporate from its solid form ice immediately into gas without going?
That's called sublimation.
The liquid portion.
And that's what happens under the atmospheric conditions on Mars if you put ice off on the surface.
It also happens on Earth if you have ice on a very low humidity day, like in Albuquerque or something. It will sublime back into
Well,
the
now they've pretty much concluded the moon has ice at the poles where the sun never shines inside craters, and I assume I'm assuming that that's true of Mars as well. Might the moon have a lot of buried what?
No, there's the atmosphere mixes temperatures on Mars by convection. So the atmosphere gets warm and the atmosphere circulates over the whole planet. On the moon, there's no atmosphere to circulate from the warmer areas to the colder areas. So it's all done radiatively. So if the sun shines on it, it gets warm. If it doesn't, then it gets or stays cold. So there's nothing like that that's hidden on in the latitudes of Mars. But there may be, and there probably are, there are pictures of collapsed lava tubes and holes and caves apparently on Mars. And there may be ice in there that's not shined on by the sun, but it still is becoming, it's subliming back into the atmosphere if it's exposed to the air.
So it just can't survive as water in any form on the surface of Mars.
Not for very long under the present condition, but apparently billions of years ago, it could and probably did survive as oceans or lakes on Mars.
Well, yeah, you mentioned moments ago, it blew me away, kilometers thick, deep, if you will, an ocean?
Not kilometers, meters.
Meters.
Meters to 1,500 meters. That's the speculation from the Caltech study.
Which is 1.5 kilometers.
Okay. Still, it went into space. But what's left over is underneath. We got to dig it out or find it in
Ron,
caves.
the point is, they used to think that all of that pretty much went into space by being ablated off by the solar wind. But now they see that process is insufficient. And so they're saying it's soaked into the ground and it was combined into the minerals. So there's a lot of water still left.
Okay, and science believes that we got most of our water here on Earth from the incoming comets that hit the Earth, and there were plenty of them to give us all this water we got. So the same thing must have happened to Mars back then.
Yeah.
Right?
Yeah.
Okay, that's good. That's fascinating stuff. What's the status of Ingenuity, the drone, Mr. President? Do you know, or anybody?
I saw a photo the other day taken by Perseverance. They have the Ingenuity about halfway off. It's tipped down. It's a complicated maneuver to get it off the bottom of the Perseverance, and then for Perseverance to drive off and stand it up. So they're in the first stages of that.
Okay, and it's going to be. Do we have video of Mars movie? We do, don't we? I saw a Dust Devil. Was that from Perseverance? A little cyclone went by.
They did show one, yes.
Okay, so as that atmosphere is, it can call up little twirls, little cyclones, can it? Hey,
Yeah.
look who's joining us.
Hey, Bruce.
Another beard. How are you, Bruce?
Finally got it.
There you go.
Perseverance is run by a nuclear reactor on the back, and thermionic, whatever it is, heating element from an isotope.
Thermal piles.
Thermal, yeah. So it doesn't rely on solar panels, and it does not fear the dust storm unless it's going to
Okay. Well, I read that they were hoping it didn't hit the Perseverance. It's been known to dust up some of the past rovers and shut them down.
Yeah.
Well, that's because the past rovers relied on the solar panels, Ron. But
Right.
what they're worried about is Ingenuity would be fairly susceptible to wind, and they don't want to set it down. We got to wait till Bruce quits scratching here. They don't want to set
Okay.
it down and then have the wind blow it over. Even though the wind, the atmospheric density is very small, the Ingenuity is aerodynamically attuned to Mars to try to fly, and the wind could blow it over or mess with it, and they don't want to deal with that.
And I understand Ingenuity has not one, but two cameras on board when it does fly next week.
Yeah, it has a low resolution black and white camera, and it has a color camera, medium resolution color camera.
Where is the microphone? Is that on the lander itself?
Yes.
Okay. And all it's picking up really, other than really light wind sounds, is its own creaking wheels, isn't it? Pretty much. I'd like to welcome aboard active SBAU member Bruce Murdoch, who's also president and guiding force behind our Santa Barbara Theater Organ Society. How you doing, Where'd Bruce go? Well, there you are.
I'm here. Incredible.
What's going on with you guys? Yeah.
Well,
nice of you to join.
we spent a lot of time this summer when this theater's still closed. In fact, we were down there doing a video that should appear on TV here sometime. The vice president and I spent about 650 hours down there correcting things, fixing things. And hopefully it's all working now.
Yeah, I wish there was a way we could tie you guys in with a film festival. That's about to happen, and it's pretty much all virtual, except for they're doing a drive-in theater down at La Playa Stadium parking lot or something. Did you hear about that? Or the film festival?
Yeah, I saw it in the paper,
Yeah.
the news press.
Well, even if you don't own a scope, my friends, should you have an unbridled interest in this stuff like I do, fascination for astronomy, do come join the Santa Barbara Astronomical unit by clicking on contact tab of our webpage, www.sbau.org. And tomorrow night, join us for the telescope evening. We were on Mars. You want to go to the nightly?
No, let's go to the Nova thing, the very first topic that we had on the.
Oh, yeah. Okay. This is in Cassiopedia.
Yeah, there is a nova that is increasing in brightness, and the way you find it, Chuck, or Tom, could you put up the picture of the sky?
Yeah.
Okay, so now if you look over on the left, there's the constellation of Cassiopeia, and two stars are identified, Schetter and Calf, at the bottom of the W. And if you look, okay, hold it steady. So you draw a line between Schetter and Calf, and then you continue that line about the same distance down, and you come to the nova. Now, reason I put this up here is not so much about the nova. I mean, you can look at that, and that's very interesting. But if you show the whole frame, Tom, zoom out so you show the whole frame of the picture. I wanted to show this because when I first learned to do astronomy in the backyard, my parents' house, in the 1960s, I didn't have a go-to telescope. They weren't available then. I didn't have setting circles. So we did something called star hopping. And because I did this in the 1960s, I call it an ancient art and sometimes a lost art. But it helps you learn the sky really well. If you don't have a telescope, you can look around at these things. And if you look over on the other side, you see Ursa Major. And Ursa Major has the Big Dipper, and it has a handle. And the handle is slightly curved. So if you imagine that's an arc, and then you continue that arc on down, you come to a star, a bright star called Arcturus. And that's one way you can identify that star. Now there's other little mnemonics that we had that I used. If you look, if you draw a line across the Big Dipper's bowl, right across there, and you continue that line out, you will come to M81 and M82. So that way, and it's about the same distance out, maybe a little longer. So what you do is you go to your star map and you look at what objects you would like to find in your small telescope, binoculars, or by naked eye, and you work out these little methods of using stars to hop to what it is you want. If you look at again at the Big Dipper, the handle, you see the last star in the handle down there. If you go 90 degrees south from there, which is up to the right in this picture a little bit, you come to M51, the Whirlpool Nebula, which is a double galaxy. And especially in the north part of the sky like this, because that's the one I learned, you can use this technique of star hopping to get around and find virtually everything without your go-tos having to be set up. It's handy for when we do outreach because we can just point our telescope. We don't have to rely on getting our computer calibrated and stuff, which in my case sometimes fails. So anyway,
have you been able?
Go ahead.
Have you been able to see the nova?
It's about 8th magnitude, I think now, isn't it?
Yeah, because I've been looking out every night, and I like 3 nights ago I could see 3 stars. Last night I could see perhaps 6 or 7.
Well,
You know,
Bruce,
the sky
it's not
just,
naked eye.
but I mean, I couldn't even see Cassiopeia.
Well, then you're not.
It was just washed out. It was in the the sky was quite bright.
Yeah, the Great Lantern is up.
The center star in that picture we're looking at is Polaris, right? The North Star. We're looking north.
Pole, roughly.
Is it the final star in the handle of the Little Dipper? Is that Ursa Minor, Little Dipper?
Yeah, where the cursor is circulating.
Yeah, right.
You identify, because Ursa Major is a fairly faint constellation, and Polaris is a 2nd magnitude star. So sometimes here in the city or near the city, you can't see it well. So you go to the Big Dipper and you take these last 2 stars of the bowl, and those are called the pointer stars, and you draw a line straight through and it hits Polaris. That's how you can identify that the faint star, because there's a lot of stars around there that are 2nd magnitude. That's how you can tell that you've got Polaris. If you line your scope up on another star, you're going to be frustrated all night.
Well, speaking of frustrated, I'm trying to remember what Cassiopeia is. It's
Queen of Ethiopia.
What?
She's a queen of Ethiopia.
Oh, it's a queen?
Right.
Well, mythology, yeah.
Right. The major stars in there kind of outline her chair, her throne.
That's what I was about to say. Is that a chair? And then I thought that can't be a chair. They don't have a chair in the sky as a constellation, but that's exactly what it is, a sideways W. Now, what's the nova? What does that mean? What has happened there?
Nova
Create a new star?
New star, Ron. And it comes from the Latin for new. It's a new star. And so this is where a white dwarf star was siphoning material off a companion star that it's orbiting, and had basically collected enough on its surface that the temperature and pressure was enough for a thermonuclear reaction, blowing that stuff up and making it brighten. So it suddenly got brighter, and that's the definition of nova, really.
And it'll do it over and over again.
Right.
Possibly. This may be a repeating one. It may not be recurrent.
So will it ever get big enough, bright enough to see by the naked eye?
Doesn't look that way.
Yeah, it doesn't look that way.
Okay.
Yeah, I was able to see it about a week ago with binoculars, but I couldn't even see Shutter. I could see calf, and I just said, okay, it's got to be about there, and I could see it, but it was just a dim, washed out thing.
Yep, that's it.
Is it part of a? Is it now part of a binary?
It
Well,
has to be part of
been
the
a
binary, yes.
It'd probably be
It's
the
not newly a
smaller.
part of a binary. It's been part of a binary for its life.
But it's not
Oh.
a visual binary.
But mostly stars are created out of just a lot of dust. Is that what happened here? It's
Yeah, like
No,
the
it's
picture
not
shows.
newly created, Ron. It's a white dwarf star, and it's siphoning material, as you can see in this picture. And when enough
Okay,
collects
there-
on the surface, it can cause a thermonuclear detonation that brightens it up. May or may
Oh.
not destroy the white dwarf.
well, white dwarfs are a little hotter and more active than red dwarfs, are they not?
They're
Oh,
hotter,
big
yes,
time.
and denser, but they're not active in the sense that they're not doing thermonuclear reactions in their core. They are
They're
just
dead.
radiating away heat from their
Yeah.
formation, from
Yeah.
when they were the core of a star, basically.
Yeah, they've expended their life and they're coasting now.
Okay. So
And
we're
Ron,
looking.
Ron, what's
Yes.
amazing to me, Ron, is that this white dwarf and this star, they're no farther apart than the Earth and the Moon. It just amazes me that those two stars can be that close together.
And this isn't scaled to size. The white dwarf is probably on the order of the size of the Earth, maybe a little bit bigger. Whereas the star it's siphoning material off of is likely much, much larger.
So they're spinning around each other about one of our Earth days or 2 or 3.
Fairly
I think
quickly, yes.
hours.
Wow. And who was it? Japanese guy on his telescope discovered that, right? Several weeks ago.
Yes.
An amateur,
Do we have a
Nakamura.
name for? We have a name for it.
Last week, I think it was Nakamura.
It's going to be called Nova Cassiopeia 2021.
Right.
Okay. But it's only for people with telescopes. The rest of
Yeah.
us ain't going to be able
Or,
to see it.
or
even with-
binoculars.
or binoculars. Okay. But it's nice to welcome it aboard. This happens very seldom, right? We don't get new flare-ups in our galaxy that often, do we?
Well, this probably relatively common. This
Really?
isn't a supernova, Ron. This isn't when a star blows up. Totally. I mean, it may.
Oh, this is
but
when it's created. Well, okay. Shall we go on to the next topic, gentlemen? We did water on Mars. We've got the new nova. And you want to do the night sky, gentlemen? I've just encapsulated salt and pepper cluster tonight. We have a full moon, something in Auriga, the Charioteer, and M37, and the western sky after sunset. Any comments? You guys out looking?
I was out last
For
night
tonight?
for 2 occultations, but
Wow.
the sky's pretty bright with that moon out there.
Yeah.
Mhm.
Gary, you post the nightly looks from, what is it, Astronomy or Sky and Telescope
No,
magazine?
I clip these things and edit them from Astronomy magazine.
Okay. Well, if you feel like, what is the salt and pepper cluster? Can you tell me that?
I think Tom's got it up there. It's an open cluster. Auriga is a
That's the
nice.
salt and pepper.
Yeah, Auriga is a nice constellation for looking at when you have the bright moon up, because you can see a lot of open clusters in there. So there's not a lot of faint fuzzy nebula we're trying to see. Tom, could you go back 2 pictures ago? One more there. And this is what it looks like in a scope, a good scope. And you notice there's a bunch of red stars in there. This is an excellent photograph, whoever took it, because it's got really good star colors. A lot of amateur photos. This might not be an amateur photo, but the stars are pretty much all white. But this has captured the really good red giant stars. And these especially shine when the sky is brighter. If you look at the double cluster, for example, when it's still not dark night, it's the end of dusk. You can see it emphasizes the red giant stars. It's very pretty. And here in this same case, this cluster also would be one to look at in a bright sky because it enhances the color difference of the stars between white and red.
And the presence of those red dwarfs is kind of an indication that this is an older open cluster where some of the stars have evolved off the main sequence.
Yeah. Now what happens?
That happens to be one of many, many star clusters where typically the stars are light weeks or light months away from each other, not light years. And there's thousands.
Yeah.
Light years, really?
If you look at the backdrop behind Chuck's head, that's the Orion Nebula. And
right.
Wait while we throw Chuck out. So that's where things start. And that kind of a cloud is called a star nursery. And the clumps of dust in there are forming Bok globules, which are pre-star concentrations that then will collapse under their own gravity until the interior temperature heats up. And when it reaches 10 million degrees, then it will start nuclear fusion in the core and it will shine. The star will turn on as a star and it'll shine. And when enough of these stars have formed, that's the first stage. When enough, you can come back, Chuck. When enough of these stars have formed, it blows the dust away. And then the first thing you see after these stars have formed and the solar winds blow the dust away, then you get an open cluster like we see, what was it, M37 we were looking at. Our sun once went through this process, but that was several 5 billion years ago. And as a result, our open star cluster has slowly drifted apart. So we don't see the star cluster we were once in. There is an ongoing research project to map local stars with their motions and then map them backwards to see if they came anywhere near our sun. First, you find a star that has a similar composition to our sun, and then you trace it backwards in its orbital motion around the galaxy center. And they've identified a couple of stars that way that probably formed, they're sister stars to our sun, that probably formed in our nebula and then were in our open cluster. But here you're looking at open clusters. There's 3 of them right there in a row that are very early on in that process. We were in that process 5 billion years ago.
Well, I have a question, Mr. President. Any one of you might be able to answer this. Like our own solar system, which formed in a similar big cloud of dust, why don't they just collect and become a star? Why do they start swirling and we get planets? Is that similar to the hurricane production on Earth?
There's turbulence, there's random turbulence and motion in the clouds, Ron. And so as they start to collapse, you end up with some net angular momentum in the cloud. And then just like an ice skater, as it condenses down farther and farther, it begins to spin more and more.
Okay, so pretty much this happened to all the stars. They seem to all have planets, and those planets wouldn't be there if they didn't have the spinning thing you're just talking about. If the dust just collapsed quietly and serenely on itself, it would be one big star by itself, wouldn't it?
Right. If you just had no net motion, it would just collapse directly down into a star.
Does that ever happen? Are there stars out there with no planets? For sure, we know.
There are stars with no planets, but it's not necessarily the fact that they just went straight collapse.
And apparently there are planets with no stars too.
Yeah.
That's right. They roam in the galaxies.
Yeah.
And they either got tossed out or they didn't form with enough material to start thermonuclear fusion.
Life might be a little rough on one of those rogues.
Yep.
Okay, that's pretty much covered. Thank you. Monday, apparently the moon is full tonight, but looking at tomorrow night, it reaches perigee, about closest point to the Earth. Will it still be full?
No.
Jerry?
No.
Yeah, it was full last night.
Yeah.
Okay, so perigee it doesn't have to be full to be closest.
Right.
It can be on its way in and off center, if you will.
That's why you get these super, now anything within a certain percentage of perigee is called a supermoon. and anything far out is, I forget the term, but mini moon, you know, a smaller full moon.
But we really can't tell by looking at it that's any bigger. How much closer is it? How many thousands of miles between
It's
perigee and
5% or something. It's not a huge amount. You can tell if you take a photo with the same settings on a camera and then compare the images.
okay. There are moons in our solar system that have elliptical orbits and go way out and come back in, don't they?
Our moon is in an elliptical orbit too, yeah.
Well, it's
so is the Earth.
A perigee and an apogee.
but it's not critical, if you will.
It's not, yeah.
What's the April Fool's joke on your eyes for Thursday the 1st? Anybody want to talk about that?
A blinking planetary. If you look at that planetary nebula, it's
Yeah.
it sometimes blends with the sky and you can't see it, and then you look again and it's there, and then you look again and it's not. Now with my aged eyes, I have more than the blinking nebula that do that, but that's their April Fool joke.
This is one of Tim Crawford's favorite nebulae to look at too, because he likes to show people that if you stare directly at it, the nebula seems to go away and you only see the star.
Yeah.
And then if you look at it with peripheral vision, you can see both.
Is this the one that's supposed to look like a human eyeball or an eye?
Several of them look like that. This is not what you'll see in your telescope. This will look like a slightly flattened out star. It'll look like a star, but just a little bigger.
I see. Does require a telescope. Okay.
It does. I think, yeah, it does.
And the best night to see that would be next Thursday, the Thursday of this week, which would be the first blinking planetary nebula. What does that mean, planetary nebula? It means it makes planets?
No, Ron, these things are the dying phase of stars when they poof off their outer layers as they're heading toward a white dwarf, okay? So that's probably a white dwarf in the center there. And in the 1860s, when they started to look at these things with telescopes in the 1600s and onward, they saw that they looked like they had a disk, like they were planetary, but they weren't moving, they weren't orbiting. And they could tell that they were cloudy, that they weren't a single star. So they called them planetary nebulae, clouds that look like planets.
Oh.
They actually have nothing to do with planets. In the 1860s, when they got spectroscopy, they could see that they see a single line of like fluorescing oxygen coming from these things instead of the spread out spectrum you see from a star. So they knew they weren't stars, and they knew that they were clouds of gas by then.
Oh.
Can you find a picture of M1?
All right.
These planetary nebulas, this will be the
Oh, crap.
M1 is not a planetary, though.
No.
M1's a supernova remnant.
Right.
Right.
But it's also, yeah, oh yeah, we shouldn't go there because that is a different class. So this is fine, M57.
That's the first body that...
This is the end stage of our sun.
Okay, is that M1 would be the first one Messier discovered?
Yeah,
well, it's the first one on this list.
Yeah, but it's a supernova remnant, Ron. So we're not going there. Instead, This is the Ring Nebula, 57.
Right.
Ring Nebula, M57.
Similar look, but different process entirely.
Isn't there a count going on, or some astronomers, is it still going on this time of year? They call them Messier optics because you can see them all?
Yeah.
Okay, the marathon.
Here's a really deep picture of the ring. Look at that. How much more structure you can see.
With a long exposure
that's
photograph. You can't see this visually.
Wow. I could see how a lot of confusion back in the early days, not knowing whether it's in our galaxy or not.
Right. And galaxies had spiral structure, and they thought they were where the clouds were forming into stars in our galaxy. So they called them spiral nebulae. But then they saw that, wait a minute, these things are really far away, and they don't have this gaseous spectrum. So they're not clouds of gas collapsing into stars. They're made up of stars. And that's how they discovered that galaxies were actually external to our galaxy.
Okay, so Messier had no idea. He just, the brightest stuff up there, he put his M on, and some of them are in the galaxy, others are not. They're just brighter things.
They were just faint fuzzies to him. And many of
His telescope had a 1-inch diameter objective?
3.
3. Oh, wow. I didn't know.
inches.
Oh,
Galileo was in the
These,
1 inch class.
faint fuzzy things were resolved into stars eventually. So at some point, he just lumped all the clusters that he saw into these M objects too.
So rather than giving these objects names, we just call them M something, the first 80 or so.
Well, 57 is the ring nebula, so they get popular names.
Yeah, but they're not
Well, they
official.
do.
Bill.
Okay, well, we got to pay homage to our founding fathers, I guess.
Yeah.
Can we do Friday, the 2nd of this week, as long as we're wrapping it up for the night sky? Jupiter and Saturn.
Yeah.
They're visible all week, though, aren't they? More easily visible in the pre-dawn hours. You guys out watching this, or do you have a sky to see it in?
Yeah, Jupiter's well up. in
Jupiter
the,
and Saturn, where are they going to?
Also, the
What'd you
International
say?
Space
Whittemore,
Station is
where?
making a bunch of good passes starting on the 1st for about a week in the evening sky.
I forgot to write that. Can you tell us when? You had it written down somewhere. There's two
You got to go
passes a night.
to heavens-above.com and look it up, because there's sometimes 2 passes in a night, and I don't remember all the times they're coming over.
They don't all go northwest to southeast, do they? They go sometimes southwest to northeast.
It's generally west to east, but yeah, it can vary whether it's a southern or northern trajectory. Generally, they start out on one and then they flip over into the other in the course of a week.
And this does not involve a telescope at all. It's all
No
naked
telescope
eye.
necessary.
Nope.
We saw the, somehow you knew it was a Chinese unoccupied orbiter
Tiangong
outside
1
in
and
one of our,
2.
yeah. Is that still up there?
I believe so. It's not occupied, but it hasn't re-entered yet. The second one. I think the first one re-entered.
Mm-hmm.
Well, speaking of China, they're orbiting Mars now, right? They haven't settled their rover down yet.
Not yet.
That's correct. Yes.
And it's called something Wen.
Tianwen.
Tianwen. And supposedly, like they normally do, they're pretty secretive about it. Does that mean we don't know what they're going to look at? Or wasn't it going to land near one of our earlier rovers, Curiosity or Opportunity or whatever they mean?
I don't know that they announced where they were going to land their rover. They may still be deciding that now that they're in orbit.
And it's a little smaller than.
I don't
Go
know
ahead, Jerry.
to land near one of ours. No.
Okay, well, that's something I saw on fake news from YouTube. There's a lot of garish, crazy projections. And
Last week we showed pictures of the Apollo 12 landing site on the moon, and that landed
That's
near
right.
one of the Surveyor spacecraft at landers, and they walked over and with bolt cutters cut parts off of that lander and brought them back. So
did they really?
yeah, we
Wow.
landed near one of ours, but I don't think anyone else did.
Amazing. And we could see it from above the orbiters. We have one orbiter, two. How many orbiters?
We have
How
a
many
lunar
countries?
reconnaissance orbiter, and that's where they photographed the landing sites from. We also
Okay.
have a Mars reconnaissance orbiter, and that's where they photographed the landing sites on Mars from.
I think we got more American human-oriented things sitting on Mars than we do on the moon, don't we?
I think we're the only ones to land something on Mars that has worked after landing.
Yeah. And
And-
Russia's the only one that managed to land on Venus. Lasted, what,
right.
20 minutes or something like that?
About an hour.
An hour?
Yeah.
For one of them, yeah.
And there's a good reason for that.
Mhm.
So,
Well, the outside temperature is 800 degrees Fahrenheit, centigrade. I mean, what I'm saying.
And the atmosphere is made out of sulfuric acid, but other than that, it's pretty bland.
This is a
What
little
does the pic-
model of the Chinese Mars rover.
oh, is this it?
It's a little
It's really
model.
small.
It's not full size.
Well, isn't it about the size of our early rovers up there, or the Opportunities and
I
Curiosities?
think it's slightly smaller than Opportunity and the other one.
Yeah,
But they're not telling.
on that, I
They're not
forget-
telling us what they're looking
Spirit.
for, are they?
Spirit and Opportunity.
That's it, yeah.
Those big panels on the side, those are what?
Solar
Panels?
Solar
Okay.
panels. So they're going to have to watch out for the dust devils.
And we don't have those on Perseverance because it's all run by
Nuclear.
Nuclear. Wow, I remember the day when they wouldn't launch nuclear for fear it might crash. But I guess when
Yeah.
you're doing it over the ocean,
Mhm.
amazing stuff.
They
There's
really
speculation-
hardened those plutonium RTGs so that they're not likely to break up in a crash.
Are the Voyagers heading out toward the edge of the heliosphere with radiation and with
Right.
plutonium?
They have the RTGs, but
Yeah.
they're running out of power by now, at,
Yeah.
40
Yeah.
years later.
But I think
Is that right? And they're going two totally different directions, aren't they? We had posted on what Mr. Wilson, our president, sent to us something called the big mystery of modern physics, the fine structure constant or constant. Do you want to talk about that, Jerry, or is that too deep for us? We only got 10 minutes.
Oh, wow. Time goes quickly. There are
Before you-
fundamental constants of the universe, according to physics, such as Planck's constant and the speed of light and the charge on an electron. And these constants, if you ratio these constants together so that they produce a unitless number, that number is called the fine structure constant, and it has a value of 1/137.
Mhm.
But just like the number 42 in the Hitchhiker's Guide to the Galaxy, there's no meaning attached to it. We have no idea what this really means, why it is that exact number. But we do know that if the number were off a little bit by a few percent, then atoms would either behave differently in our universe or they wouldn't be able to exist at all. It describes the balance between, for example, quantum, the ratio being 1/137 describes the ratio between quantum effects and electromagnetic effects. And this bears directly on a question the Baron had asked years ago on our radio show about why an electron orbiting a nucleus doesn't crash into the nucleus, because the nucleus is positive charge and the electron is negative charge. And so there's an electrostatic attraction between the two. But the fact is that because of quantum mechanics and the wave nature of the electron, it can't fit into the box to get any closer to the nucleus. It cancels itself out because its own wave function overlaps itself and drives the probability to zero. So that's what 1/137 gives us. If it were a little different, then the electron could fall into the nucleus and we'd have no atoms. And so we we wouldn't be in this universe. So the question is, why does our universe have exactly this value? Why is it fine-tuned for life? We couldn't be here if there weren't atoms. And that's the basis of a lot of speculation. There's no physical reason we've been able to find for why it has those values. And so people have speculated, well, there must be an infinite number of different universes, each with its own value of the fine structure constant, but only where alpha is equal to 1/137 is life possible. And so that's the universe we are in. And so that leads to these multi-universe speculations and stuff.
Well,
So that's
Murdoch, did you get that? Whittemore, Tom?
Yep.
Tom?
Yeah, I understand it. Yeah.
Beautifully
Okay.
said, as usual. by
I'm
Jerry.
hanging on. I got to tell you, it fascinates the heck out of me because supposedly we have an abundance of positive matter, not antimatter. Where's the antimatter? Anybody considered maybe there's whole areas of the universe?
There's antimatter in the universe, but it quickly disappears, or else it's separated far away from everything else. One of my physics professors talked about first contact with an alien species, and it's just communication by radio or whatever. And you describe the whole thing, and people learn to talk with each other through mathematics. They discuss physics with this alien race, and they discuss parity and nuclear and quantum physics and agree on everything. And then finally one day they agree to meet and have first contact. So they both fly out to deep space halfway between the two civilizations. And the professor said, if you go outside your spaceship and the alien is coming toward you and you stick out your right hand to shake hands with him and he sticks out his left hand, don't take it. because he's made out of antimatter.
Yeah, there'll be an explosion like you wouldn't believe. Well, you'd never survive.
No,
it, I
you wouldn't
guess.
believe it. You wouldn't even know about it.
Yeah.
And Ron, there does seem to be an asymmetry in the reactions that occur in some of these, nuclear reactions with the small particles and stuff that show a favoritism toward our form of matter rather than antimatter. So they think that not as much was produced after the Big Bang. What was produced mostly annihilated with normal matter. And so that's why we have a universe that seems to be dominated by normal matter, although we can't know for sure.
Yeah. But we have produced antimatter in reactors, and we've even produced antimatter hydrogen atoms. And they behave just the same as our hydrogen.
Since we're in a world here in our portion of the universe or in our galaxy that's all positive matter, if we were to look at a distant galaxy that was made of antimatter, would we be able to see it?
Sure.
You'd be able to see it, but you wouldn't know whether it was antimatter or not.
Right.
Oh, okay. It doesn't disappear like dark matter.
Mm-mm.
It's, in fact, dark matter, well,
it's positive matter.
It doesn't put out anti-light.
Right. Good point.
Just one final question, Jerry, about what you brought up concerning the atoms and the electrons. Electrons have some mass, but they go the speed of light. Light has no mass. It's all energy, right? Electrons have a dinky little negative charge, and that's it. There's enough. And you gave us the reason why it doesn't crash into the nucleus, but it travels. If it goes anywhere, it goes from 0 to 186,000 miles.
No, it can't go the
instantly.
speed of light. No thing with mass can achieve the speed of light.
No.
Electrons go at whatever speed you make them go at.
Right. Electrons don't go the speed of light, like Bruce said, they couldn't. Typically in a hydrogen atom, the electron goes about 15% the speed of light as it whirls around the nucleus, just roughly.
Well, how about through a wire?
Oh, no, that's drift. That's real. You can actually, if you could see the electrons, you could actually watch them move.
Yeah.
That's a drift velocity.
Yeah, exactly.
They bounce off the atoms.
But through a wire, information travels at the speed of light.
What does?
Information.
Information.
You push one
right.
electron in one end of the wire and another electron pops out the other end, but it doesn't have to be the same electron traveling across the wire.
Yeah, that's right. Mm-hmm.
But now we've got all these other confusing little particles like neutrinos are going through us by thousands and millions. And cosmic rays, are they going the speed of light? Are they mass?
Yeah,
or are they just pure energy?
Yeah. Cosmic rays? Those are like high energy protons, right, Jerry?
Well, there's all sorts of, ionizing cosmic rays and there's gamma photons.
Those are speed of light.
Yeah.
Getting a little heavy here, but I'm hanging on. Listen,
well, in terms of trying to accelerate.
Go ahead.
In terms of trying to accelerate something that's got mass, there's this nasty little expression that's in the denominator called 1 minus v squared over c squared. So when v squared becomes almost c squared, 1 minus that is a number that's tiny, and that's in the denominator. So it makes the thing that it's modifying very, very large. And when you get to the speed of light, it's whatever it's modifying, the thing becomes infinite.
Yes.
You can't divide by 0.
You've used all the energy of the entire universe to get that particle to the speed of light.
Right.
That's right.
But everything that emanates from the electromagnetic spectrum, from the lower radio waves, clear up past color and into X-rays and gamma rays, that's all photons, just going different frequencies, right?
That's right.
That's the photon wave duality. It can be. You can look at it either way. It can either be a particle or it can be a wave.
Well,
E equals h nu.
That's the
equation. That's the relationship.
We could get into that and lose our audience.
Maybe we already did.
Maybe we already did. I wanted to say before we close out, gentlemen, would your school or organization like a virtual outreach class discussion, possibly online via Zoom, and contact our outreach coordinator on the screen there in the middle on the right. Chuck McPartland at Outreach.
Baron,
I'm sorry, what?
Your voice blanked out. Repeat that.
Oh, okay. Class discussions, you've had a couple already this year.
We
They
had a couple
contact
of
you at,
virtual
what is
star
it, outreach?
parties and one class event.
Okay. And you're looking forward to the days when you could pack all that stuff in your little, what do you got? A
SUV.
heck do you drive? It's SUV. Yeah. Go out to places where you set up in the backyards or in the schoolyards. And then we used to have our second Saturday star parties following the board meetings. Boy, we miss those days, don't we?
Okay, we'll get back to that.
We'll get back to it.
What are we going to watch tonight, Bruce? What are you working on?
Well, I wanted to try to photograph that nova, but the sky has not been cooperative.
With the
Okay,
haze and the full moon, it's going to be a pain.
Yeah.
Yeah, well, I figure if I can't see the guide stars, since it's a much dimmer. I mean, I did see it once with my binoculars. I was able to, look at Shetter and then Calf, and I sped over, and there it was. But I get a high cloud later here. It seems to be almost every night. You look at the moon, and it's got a big aura around it.
Imaging will be a little easier, but still ugly.
Yeah,
Going to be up there. Going to be up there for a while, though. I ain't going away anytime soon, right?
It'll gradually dim.
Shame on you, Chuck. The moon is not ugly.
Well, when they had the nebula, I'm sorry, the nova in M82, that
Supernova,
lasted about 2 weeks, and then it faded.
Yeah.
That's a
I got
supernova.
pictures
That
of that
goes
one.
on a little different schedule, but yeah.
Right.
Okay.
Yeah.
So Chuck,
about
are you
you?
saying that, are you saying, Chuck, that the current nova is actually at its maximum brightness right now?
I don't know.
Yeah.
It seems to have peaked though. It was coming back down.
Yeah.
I'm not following it real closely.
Yeah.
A week ago, it was rising in its brightness, but I don't know about now.
Okay.
But this isn't a Cepheid variable we're talking about here. That's your
Oh, no.
expertise. Okay,
No,
what
it's-
about our next? What
Oh,
about
just
our
two stars
future
in-
podcast? What?
I just say it's two stars in very, close proximity. Like Chuck said, little white dwarf is dragging information off the other star, and gets enough on its surface, it'll have a thermonuclear reaction, and it'll flare up, and you may be able to see it. So,
But my understanding is that more than half those single little dots of stars out there are doubles or triples, aren't they? That we just see as one.
But they're not necessarily close enough to have this sort of
Right.
symbiotic relationship like you have with the white dwarf.
right.
It's closer, right? Than most
Yeah, it's
of
really
them.
close.
Yeah.
And yet you're trying to see them apart.
No, he's
no,
just
there's
trying
no
to.
way to that.
He's just trying to see the nova.
Yeah.
Right. You're seeing the flare up on the white dwarf. Okay.
What percentage of stars that you zero in on that are binaries or triples can you actually see the delineation in both of them, or triple, the three of them? Or
That's
do
a
they
fair
all-
number. A
Yeah,
visual,
really?
a visual binary. There's
Well,
some
that's
you
naked
can
eyes
are an
lifetime you can
Alcor.
trace the orbit.
Fascinating stuff. How are we doing on time, Tom? We get down to the last minute or two, aren't we?
Right. I just wanted to mention that we did have a visitor for a little while. He visited from Brazil. His name
Wow.
was Fabricio.
Wow. neat.
Really? Visitor as in what? Watching us?
He left a comment on our YouTube page there as we're going.
Oh, that's neat.
Uh-oh. Can you read it to us?
Was it a good comment?
I don't know if
But
mine-
he just said, BR, let's see, good afternoon, boa tarde, hello from Brazil, Rio de Janeiro.
Uh-huh.
Oh, he's down there now watching us?
He lives
He
there.
was. I think I'm the only one watching now at the moment.
Well, I'm looking at my clock and it's down to the last minute, I have a feeling.
Okay.
Run out of time. Anybody want to make some final statements, gentlemen, before we tune out for next week? Whittemore?
The newsletter is done. I sent it to Chuck this morning, and so you guys can enjoy that.
I'm going to try to squeeze in a couple of little more things.
Oh, good. Please, Chuck. There's plenty of room, and I loved your April Fool thing.
Oh, yeah.
Chuck put an April Fool thing in there. It's really cute.
Okay.
I'm assuming we
And
don't
then
get the
Ron-
newsletter on paper anymore. Well, look,
on our
gentlemen.
website.
All right. Website is what? SBAU.org. Thanks for
That's right.
sharing everything. Take care of yourselves and your wives, and we'll see you next week. Everybody, thank you. Stay safe.
Thanks,
Thanks a lot.
Ron. Thanks, Tom.
Appreciate it. Take
Bye-bye.
care.
Bye.